Right, this next section is on what we call the common ion effect. When we have a solution that we're making and one of the solutions already has one of the ions that we're interested in already in that solution, then it changes the ion product, the solubility product. And so we need to take into account when that kind of situation arises. And so we need to look at special situations where that is in fact the case, because it does change where the equilibrium position will sit. If we lower the solubility of an ionic compound by the addition of a common ion, it's called the common ion effect. So let's try an example here. Determine the molar solubility of silver iodate in a 0.01 molar solution of potassium iodate. The KSP of silver iodate is 3.2 times 10 to the minus 14. All right, so what we're looking at is this particular equilibrium where silver iodate goes to silver ions and iodate ion. So the KSP of this is going to be the silver ion concentration times the iodate ion concentration. Now, if we have a solution that already has some of the potassium iodate, the iodate ion in there, that's going to affect this KSP value. And so, well, it's going to affect the relative concentrations of these two ions. So what we need to do then in this is we would normally just say, okay, so let X be the concentration of the silver iodate silver ions, and then the X would also be the concentration of the iodate ions. So we would have X squared is equal to the KSP value, and so then we can take the square root of the KSP, and that would be our concentration of each of those ions under conditions where we just have the silver iodate ions, the silver iodate compound in solution. However, when we already have some iodate ions in there, now that's going to increase this value, the iodate ion concentration. So that means the silver ion concentration is going to have to be quite a bit less. All right, so let's see how this works out. So the silver ion concentration, let that be X, then the iodate ion is going to be X plus what's already in the solution. And so then when we multiply out the brackets and solve for X, we're going to get this little quadratic here. And so X is going to be the 3.1995 times 10 to the minus 12, or negative 0.01. Well, we can't have negative values, so that's not it. So that means our molar solubility of the silver iodate ion is going to be 3.2 times 10 to the minus 12 moles per liter. Okay, that's all the silver iodate that we're going to be able to dissolve in this solution. Okay. All right, how about the solubility of copper iodide, copper 1 iodide, which has a KSP of 1.1 times 10 to the minus 12, and we put that in a 0.01 molar solution of copper 1 nitrate. Okay, same idea. We set up our equilibrium. Okay, our concentrations would be, our KSP value then would be 1.1 times 10 to the minus 12. Concentration of the copper would be the X plus the 0.01 molar, because we've got some copper coming from this. And the iodide ion concentration is just X. Solve for our quadratic. We get the two values again. One is positive, one is negative. The negative one doesn't make any sense, so we can get rid of that, which means the other one has to be our concentration. And so we would have a molar solubility of 1.0999995 times 10 to the minus 10, or 1.3 sig digs in this situation. No, 2 sig digs. So 1.1 times 10 to the minus 10. All right. try these homework questions, and we'll take up problems in class.